So in this question number 7, they are asking about to give some advanced method to find the median of some very big data sets, right? So like, why do we need some complex methods? Let's just first understand about it first, right? So let's just say I have a data set, a very small data set and a kind of a random data set. This is kind of randomized. So whenever you want something very insightful to know much more about the data set, you usually take the values which are in middle of the data set, because most of the data sets follows a bell curve. So the huge majority of peoples are present between the 50% area, right? So usually you just need the median part of the data set to get some insights for that data set. So what usually happens is that to get the median, you first have to sort the data set, right? So if I say this is an unsorted data set, so if I just apply a linear sort, so it basically just compares each and every value with its other values and so on with each value, and we can just sort it out in a very simple algorithm. But this algorithm is good for very small data sets. When the data sets become in millions, or let's say in billions, so these simple sorting techniques will not work. Right? We need to first sort the data, then only we can find the median of that data. So to sort these very big million and billions of data, we have some very nice techniques which we can work on. The first is very popular one, which is the quick sort technique. So what we can do in this technique, because it is very like at starting phase, it is one of the most used sorting technique. In advanced phases, there are many techniques like KL and so on, right? So if we say of the quick sort, what happens in quick sort is that quick sort takes a random pivot, and then that pivot divides the data set into two halves, and then those two halves are then compared with each other, and then the pivot moves left and right according to the data in which way it has been transferred in these two parts, and then again the new pivots are assigned in the next iteration and so on. So quicksort sorts the data sets in a very I should say in an efficient way, right? Then after the quick sort, we have medians of median method, right? So the average time for the quick sort is O n, right? Log of n, O n. So the how many number of digits are there? It's an average time, right? It's not the best time. It's an average time. But sometimes it can go in a very bad condition and it could reach up to n square, which is similar as linear search. So it is not a kind of a good sorting technique if you just choose the pivot very bad, right? So what happens is that there is another very good technique, which is the median of median. In this method, it is just like quick sort, but in this we choose the pivot smartly. We choose the pivot which is kind of in the middle, which is kind of like near to the median, right? So the pivot is near to the median. So we usually choose those pivots and it just reduce the worst case to O(n), which is kind of good, right? Now these two are kind of techniques which like big data sets can be applied to the big data sets, but sometimes after applying those techniques, you can encounter that the RAM is not sufficient, right? So the data which is coming inside the RAM is not sufficient. So if we move outside the software world, this is the whole software, this is the whole algorithm running, right? You can enhance the hardware, or you can enhance the technique of using the hardware. So let's just say if you have a RAM of 8 gigabytes, and it just, the data can't be fitted inside that 8 gigabytes, right? So what you do is that you also use the secondary data, secondary storage, right? So what you do is that if I say if Quicksort is searching for a specific part, then you can just take that part to the RAM and like just keep the other part in a standby mode in the secondary storage, and then suddenly if he wants to use that, he can just take out that from secondary storage and so on, right? So this was a kind of a technique which if the data set is kind of big, you can use, right? So this was the end of the question 7. Thank you.